Hi guys, in this video we'll be looking at the acid-metal carbonate reaction. We'll first have a look at the reaction and the general equation for that. Then we'll have a look at an example, and then we'll work through a couple of examples together, and then I'll briefly talk about the lime water test. So firstly, when acid reacts with a metal carbonate, it produces carbon dioxide, water, and a salt. Now remember, when we talk about salt, we're talking about any ionic compound. So that is a compound with a metal and a non-metal. And in most cases for this will be a polyatomic ion as the non-metal. So an example of this equation is when magnesium carbonate reacts with sulfuric acid. And that produces magnesium sulfate, water, and carbon dioxide. So in this case, the magnesium sulfate is our salt, and that's made up of the magnesium from the magnesium carbonate and the sulfate from the sulfuric acid. So let's work through a problem together. So this one is a copper carbonate and nitric acid. So we need to work out the products. So we'll remember back to our general equation that a metal carbonate and an acid form salt, water, and carbon dioxide. So half of it's done for us. We know that there is going to be water and carbon dioxide. Now this is the point where it's good to write the chemical formula to help us work out what that salt or what that ionic compound is going to be. So we've got H2O and CO2 on this side. And on this side we have copper, which is Cu, and carbonate, which is CO3. Now both of these, copper's we're told is 2+ because of the Roman numeral 2, and carbonate is 2-, so we don't need to balance any ions here. And we can look at our acid table, and so we see that nitric acid is HNO3. All right. So now we need to work out what is going to form this salt. So what's going to happen here is the carbon and the oxygen that make up the carbonate and the hydrogen from the acid is going to form this water and the carbon dioxide. So that's where they come from. So what we're left with is the copper and the nitrate. So we know that the salt formed is going to be copper nitrate. It will be copper nitrate. Now, we were told previously that this was the copper 2+, and nitrate has a valency of -1. So we're going to need 2 nitrates for that to happen. And now that ion is balanced. Now the last thing that we need to do is work out whether this equation is balanced. So we'll start with the metals, and we can see that we've got a copper here and a copper here, all good. Then we'll have a look at the ions, and we find that we have 2 nitrates on this side and 1 nitrate on that side. So we'll put a 2 in front of here. So now we've got 2 nitrates and 2 hydrogens, which makes sense because we've got our 2 hydrogens on this side. And then we have 1, 2, 3 oxygens here, which is 1, 2, 3 oxygens and 1 carbon on both sides. So this is now balanced, and we can just write that in here. So that's copper 2 nitrate. So that is our first example. So let's have a look at another example. So here we have iron carbonate and sulfuric acid. So the first thing we need to do is recall that general equation. That this metal carbonate and acid is going to produce salt and water and carbon dioxide. So again, half of the work's done for us. It's water and carbon dioxide are 2 of the products. So this is the point where we then put this into a chemical formula. So we've got water and carbon dioxide there. And on this side we have iron carbonate. So that's iron carbonate. Now the iron, we're told, is a 3+ version of iron, and the carbonate is 2-, so we're going to have to swap and drop here. So CO3, 3 comes here, Fe2, and we look at our acid table and find that sulfuric acid is H2SO4. So as we did before, what's going to happen in this reaction is the carbonate on this side is going to react with the hydrogen, and that's going to produce our water and our carbon dioxide. So we just need to look at what is left over. And in this case, it is iron and sulfate. So that tells us that our product over this side is going to be iron sulfate. Now again, this is that 3+ version of iron, and our sulfate is 2-, so we're going to have to balance those ions, which we've done now. And then finally we'll go through and make sure that this equation is balanced. So firstly we'll have a look at the metals. On this side we've got 2 iron, on this side we've got 2 iron, so that checks out. Then we'll look at the ions. So on this side we've got 3 sulfate, and on this side we've only got 1 sulfate. So we're going to need some more sulfates here. So if I put in a 3, that'll give me now 3 sulfates. So that's all good. We'll now have a look at the non-metals. So the one that we're going to have as our non-metal, because this ion is going to break apart, we've got 3 carbons on this side because we've got 3 carbonate, so that'll have 3 carbons. And we go over this side and there's only 1 carbon. So we're going to have to put a 3 here in front of the carbon dioxide, and that now gives us 3 carbons, and that gives us 6 oxygens. So let's have a look at our oxygens. Actually, let's do our hydrogens first. So we've got 6 hydrogens here and 2 hydrogens here, so I'll have to do another one there. 3. And so this side, okay, so we've got 6 hydrogens there, so that's balanced. And finally we'll have a look at our oxygens. So on this side we have 3 times 1, so there's 3 there, and 3 times 2, so there's 6 there, 9 in total. And come back over here, 3 times 3 is 9, so that's balanced on that side. So that equation's now balanced, and we can write our iron sulfate into the word equation. Alright. Now the way that we can test for this gas that's produced is by using the lime water test. How we do the lime water test is we have a delivery tube put onto the vessel that we're doing it in, whether it's a flask or a test tube. So there's a stopper over the container with that delivery tube, and then we place the other end of the delivery tube into some lime water, and as that gas is produced, it bubbles through the lime water. Now if this is carbon dioxide, which it should be in this case, the lime water will turn a milky colour, and you can see here the bubbles here, so that's our delivery tube in the centre, and you can see that as this is bubbling up, it's going from clear to milky. So a precipitate is being formed in the reaction that occurs between the carbon dioxide and the lime water. In this video we've looked at the reaction of an acid and a metal carbonate, and we've found that the general equation is acid and metal carbonate react to form salt, water and carbon dioxide, remembering that a salt is any ionic compound. We looked at an example equation and then a couple of worked examples, remembering here that that salt is going to come from the metal that's with the carbonate and from the polyatomic ion that's with the acid. And we then talked about the lime water test to test for the presence of carbon dioxide. Thanks for watching, guys. Peace out.